Hello everyone, welcome back to our YouTube channel Scratch Learners. Today we will discuss about merge sort. In the last video we had discussed about the process of merging two arrays into one sorted array. If you haven't watched that video, please go and watch it out because this merge sort algorithm uses that process to merge two arrays into a sorted array. So let's begin with the topic. Merge sort is one of the sorting techniques which is based on the divide and conquer technique to sort any unsorted list of elements, right? That means this sorting technique uses the approach of divide and conquer. That means the list is divided into smaller sublist and they are combined back into one sorted list. The merge sort reiterates on the list of elements by dividing it into smaller portions and sorting each subportion. If we are given any list, we first need to divide that list into smaller portions and then we will sort each subportions and then we will conquer all the subportions into a single list. So let's assume a list of n elements with lower bound L and upper bound U, and we need to sort this array, right? So the main steps of this divide and conquer strategy of merge sort are divide, conquer and combine. In the beginning we will partition the list into two sublists of almost equal size. So how can we partition the list into almost equal size? By getting the middle index, right? So we will calculate the middle index as lower bound plus upper bound by 2. Here L is the lower bound and U is the upper bound. So in this way we will get the middle index, right? Now if n is even, that means if the size of array be 4, then we will get two equal sublists of size 2 and 2, right? But if n is odd, that means if it is 5, then we will get two sublists, one of size 2 and one of size 3. So if n is even, we will get two sublists of size n by 2. But if the value of n is odd, then we will get the two sublists, one of size n by 2 and the other of size n by 2 plus 1. Then the second step is to sort the two sublists recursively using merge sort. So after dividing the list into two equal sublists, we will sort both the lists recursively. And in the last step, we will merge those two sorted lists to obtain the sorted output. Now let's understand this merge sort algorithm with the help of this example. Here we are doing the top-down approach, that is the recursive approach of merge sort. In the next video, we will discuss about the bottom-up, that is the iterative merge sort. So let's begin with this example. In this example, the value of n is 8. There are 8 elements. The lower bound is 0 and the upper bound is 7, right? So in the first step, we need to divide the list into two sublists of almost equal size. So we will calculate the middle index as the lower bound plus upper bound by 2. Here it comes out to be 3.5, but there is no such index, so it will be taken as 3. Okay. So the third index, that is this index, is the middle index, right? Now we will divide these two lists into two parts. So after dividing the list at the position of middle index, we will get two equal sized sublists. The first list will contain elements from the index 0 to index 3. That means 2, 8, 3 and 7. Okay. And the another sublist contains the last 4 elements 6, 1, 9 and 5. Right? We will divide the list into two parts till we get each sublist of size 1. That will again divide this sublist into two parts. Now here the middle index will be 1. That means the list will partition from this position. So the one sublist will contains the element 2 and 8 and the other sublist contains the element 3 and 7. 0, 1, 2, 3 are their indexes, right? Now these two sublists contains two elements, right? We again need to divide these sublists into two parts. The first list containing the element 2 and the second list containing the element. Similarly, we will divide these two sublists into two parts. The first containing the element 3 and the second sublist containing the element 7. See here, all the sublists contain only one element and we cannot divide these sublists any further, right? So the step of partitioning the list into two sublists is complete for these sublists. Okay, now we will divide this sublist. Now see here, there are 4 elements. So the list will be divided, each containing 2 elements. So the first 2 elements 6 and 1 will be stored in the first sublist, and the element 9 and 5 will be stored in the second sublist, and their indexes are 4, 5, 6 and 7, right? Now this sublist contains 2 elements, so it will be again divided into 2 sublists, the first containing the element 6 and the second containing the element 1. Similarly, this sublist will be divided into 2 parts, the first containing the element 9 and the second containing the element 5. See now, this sublist cannot be divided any further because all these sublists contain only one element. So the dividing step is complete for whole array. Now we will combine these sublists by sorting the elements. So the first element is 2 and the second one is 8. There is no need of sorting, so this will stay like that only, 2 and 8. Now this 2 sublists will be combined. Here also 3 is smaller and 7 is greater, so it will be stored like this. This is a sorted sublist, this is also a sorted sublist, right? Now we will combine these 2 sublists into a single list by sorting the elements. Here the element 2 is compared with 3. As 2 is smaller, it is stored in the first position. Now 8 is compared with 3. As 3 is smaller, it is stored in the second position. Now we are left with the element 8 and 7. As 7 is smaller, we will store 7 and then 8. So this is the sorted left sublist, right? Now the same process will continue for the second sublist. Here 6 and 1 should be compared, right? So we need to swap them. 1 be stored in the first position and then 6, right? Similarly here 9 is greater, right? So 5 will be stored first, then 9. Now again these 2 sublists will be combined into a single list. The element 1 is compared with 5. 1 is smaller, right? So we will store 1. Then 5 is compared with 6. 5 is smaller, so we will store it. Now 6 and 9. As 6 is smaller, it is stored, and in the last we will store 9. So see here, these steps are nothing but the merging of 2 sorted sublists into a single list, right? I have already explained the algorithm for these steps in the previous video. Now again, these 2 sublists will be combined into a single list, and this is the final step to merge the 2 sorted lists to obtain the sorted output list. So here again 2 is compared with 1. As 1 is smaller, we will store 1 in the first position. Then 2 is compared with 5, as we have already stored 1. Now 2 is smaller, right? So we will store 2. Then the element 3 is compared with 5. As 3 is smaller, it is stored. Now 7 is compared with 5, right? 5 is smaller. Now the next element 6 is compared with 7. Again 6 is smaller. Then we will compare 7 with 9. As 7 is smaller, we will store it. Now the last elements 8 and 9 will be compared. As 8 is smaller, we will store it first and then 9. So in this way we got the sorted output. Now let's understand the algorithm for top-down, that is recursive merge sort process. So let's begin. Here we are considering an array A with the lower bound low and the upper bound up, and it is of size n. Here this is the function merge sort with the lower bound low and the upper bound up as the arguments. So if low is less than up, that means the lower bound is less than upper bound. We will repeat these steps. We will set mid equals to low plus up by 2. This is the calculation of the middle index for the dividing process, right? So we are calculating the middle index, then we are calling the same function. This is a recursive process. So we are calling the same function merge sort with the arguments low and mid. Why? See, in this example, middle index will be 0 plus 3 by 2. That means 1.5, that is equals to 1, right? So this is the middle index, and we will get to list by dividing the list in the middle index. So as we have got this sublist, we need to again divide this sublist, right? So we are calling the same function with the argument low and mid, that is low equals to 0 and middle equals to 1. So this function is called for breaking the left sublist into further sublists, right? After calling this function, we will again get here, and again if low is less than up, that means 0 is less than 1, we will calculate the middle index. So the middle index will be 0 plus 1 by 2, that means 0. So this will be divided into two sublists, right? 0 is both the lower bound and the upper bound for this sublist, right? So now again the function will be called with lower bound 0 and the middle index will also be 0, as this list contain only one element. So whatever is the lower bound, the same is the upper bound, right? So when the same function will be called, again this condition will be checked if low is less than up, but here low is equals to up. So now these steps will not be executed, right, as we couldn't satisfy this condition. Then now we will move towards this sublist, as this cannot be divided any further. So here also it cannot be divided any further, right? So we will move towards this sublist, right, as this is containing two elements and it is not divided till now. So this sublist will again be divided into two lists until it contains only one element. Here it is containing only one element, right? So there is no need of further division. So these two steps are just for dividing the sublists, right? When all the sublist contains only one element, then we will call this function merge with the lower bound, the middle index, middle plus 1 and the upper index. When this function is called for these two sublists, then it will be combined into a single list containing the element 3 and 4 in the sorted order. Similarly, when this function is called for these two sublists, then these lists will be combined into a single sorted list, right? In the same way, when this function will be called for this sublist and this sublist together, then we will get this final sorted list containing all the four elements in the sorted order. This is the same function that we have understood in the last video. We have just seen that we divided this sublist into two sublists, each of containing one element, and we had combined it back to this array, right? Similarly, here we have divided this array into two lists, each of containing one element, then we have combined it back to this array, right? Now here is the block merge with low 1 as the lower bound of the first array, up 1 as the upper bound of the first array, low 2 as the lower bound of the second array, and up 2 as the upper bound of the second array. This is the same block that we have discussed in the last video, right? These steps are just combining these two sorted lists into a single list, right? Here the element 3 is compared with 2, as 2 is smaller it is stored in the beginning, then 3 is stored, then 4 and 7 are compared, 4 is smaller so it is stored, and then 7 is stored. So in this way we got the sorted list, right? Let's find out the complexity of this merge sort algorithm. In the beginning the value of n was 8, right? There were n elements. In the second step, the value of n for each sublist becomes 4. That means 8 by 2. In the next pass, the size of each sublist is 2. That means 8 by 2 to the power 2. That is equals to 2, right? Then again, the size of sublist becomes 1. That means 8 by 2 to the power 3. So at some pass, 8 by 2 to the power k equals to 1. Here k equals to 3. See here, each sublist is containing only one element. So we can write in this way, 8 by 2 to the power k equals to 1. So 8 equals to 2 to the power k. Here what is 8? 8 is the size of array n. So 2 to the power k equals to n. Taking log both sides, we will get k equals to log base 2 n, right? So this is the complexity till we get each sublist containing one element, right? Then when we will combine these sublists into a single sorted list, this process of merging will be done in linear time. So each pass of merge sort will take order of n time. So in total, the performance of merge sort will come out to be order of n log n. So order of n log n will be complexity of this merge sort algorithm. So this is all about the process of merge sort algorithm. If you like this video, please subscribe the channel and like the video. Thank you.